Grace and peace be multiplied unto you. I welcome you to today's lesson in maths on the topic prisms. So, we are actually moving from two-sided, two plane figures, which are just shapes and lines, to solid geometry or solid figures, things that you can touch and feel. So, when you look at the following pictures, what shapes can you see? So there are different shapes in the pictures here, and we will get to know the names of the various shapes of the pictures you see. Okay, so the topic we'll be looking at is solid geometry, and specifically we'll be talking about prisms, pyramid, cylinders, cones, and spheres. But for now, we'll start with prisms. So our learning outcomes is that we want to state the geometric properties of prisms and pyramids, cylinders, cones, and spheres. And we want to draw the nets for prisms, pyramids, cylinders, and cones. So you get to know the meaning of nets. States and find surface areas of the prisms, pyramids, cylinders, and cones and spheres. Okay, so what type of surfaces do cubes and cuboids have? Cubes and cuboids are also prisms. So we will look at the definition of prisms soon. But then when you take a look at the following pictures, you realize that they are things you can touch or things we've seen before. This is a sphere, this is a cone, this is a pyramid, this is a cube, this is a cylinder, this is a prism, a rectangular prism, and this is a cuboid. So these are items we've seen before, and these are shapes we've seen before, and they have their properties. So we'll get to look at the properties soon enough. So let's look at the definition. So solid geometry is concerned with three-dimensional shapes. And when we talk about three-dimensional shapes, that is what we call 3D. We are looking at length, breadth, height, length, and breadth. And this is what we call three-dimensional. So height, length, and breadth. So out of this, I can get a three-dimensional shape. Just look at it. So something like this, the length, height, and breadth, I can actually get a three-dimensional shape. And this is a three-dimensional shape. So 3D simply means height, that is one dimension, length, another dimension, and breadth. So some examples of three-dimensional shapes are prisms, pyramids, cylinders, cones, and spheres. And when we say three dimensions, they are models that you can actually bring into existence and touch. And they actually, all 3Ds have volume. It means they can contain some amount of material. If it's water, 3Ds shapes can contain water, or they can contain something. So let's look at their properties. Prism. So a solid with two congruent parallel bases, which are polygons. So a polygon is any figure that has three sides and above. Three sides and above. So we have a triangle to be a polygon, a quadrilateral, a square to be a polygon, pentagon to be a polygon. So all these are polygons. So any 3D figure with congruent or parallel bases or sides, meaning that once we have some of their sides being parallel, and then they have a shape such as this, then they can be referred to as a prism. So this is what we call a rectangular prism. What I've just drawn is a rectangular prism, and a triangular prism will look like this. This would be a triangular prism. Okay, so they are named according to the type of polygon they have as their face. Pyramid. A pyramid is a solid with a base which is a polygon and triangular sides that converge at a vertex. So you can have different pyramids, and a pyramid actually has a base which is a polygon. Could be 3 sides, 4, 5, or 6. For example, let's look at a base like this. This is a rectangular base, right? And this is also a polygon. Now, in order to make a pyramid out of this, they all have a sides that move up and connect at a point, and this makes it a pyramid. So you can actually have 5 sides like this and form a pyramid out of it once they go together up to meet. So this will be a pentagonal pyramid. Cylinder. So cylinder is a solid with two parallel congruent circular faces and a curved surface. So a cylinder has a curved surface and it has two parallel circular faces. So there's one circular face here and there's another circular face there. Cone. A solid with a circular base and a vertex. So cone looks like this, and then the vertex is at a point here where there's something like that. And a sphere is anything spherical that looks like a ball. So that's examples of sphere. Now let's look at prisms. We have different types of prisms, and like I said, we have rectangular prism, and this is named rectangular prism because of the face here. That's a rectangle. You have a triangular prism. This is named a triangular prism because of the face here. That's a rectangle. That's why it's called a rectangular prism. You have a hexagonal prism because of the face here. Hexagon is actually 6 sides, so 1, 2, 3, 4, 5, 6 sides, and because of that we call it hexagonal prism. Let's look at pyramids. We have square pyramids because the base is actually a square, 1, 2, 3, 4 sides. Rectangular pyramid, the base is a rectangle. Triangular pyramid, the base is a rectangle, a triangle. Hexagonal pyramid, the base is hexagonal, and pyramids meet at a vertex at the top here. So they have straight lines that connect to meet at a vertex. So faces, edges, and vertices. So for every 3D figure or every solid figure, they have faces, they have edges, and they have vertices. Let's look at what the face is. So a face of this triangle is this part. All the part is a face. Okay. Now, edges are the lines that connect each other. Those are edges. And vertices are the points where the lines meet. So, for instance, this point is a vertex, this point is a vertex, and a vertex. Okay. So for this solid figure, which is a rectangular pyramid, it has 5 faces, 8 edges, and 5 vertices. So when you count them, that is what you realize. Let's count the faces. We have 1, 2, 3, 4, and the face under is 5. And the edges, we have 1, 2, 3, 4, 5. The dotted lines are apart. 6, 7, and 8. 8 edges. And the vertices are 1, 2, 3, 4, 5. 5 vertices. So just like a cone, similar to a cone has 2 faces. You know that a cone has 2 faces. This is one of the face, and then the second face is the circular part. So when you roll this part, in this direction, then you fix it to this part here, then you have a cone, and it has one vertex, and this is the vertex, and two edges. The two edges are 1 and 2. So the two edges are 1 and 2. Those are the edges. And so you can actually count the number of faces and edges for the triangular prism here. So let's look at nets of geometric solids. A net is a two-dimensional figure that can be folded into a three-dimensional solid. So have you ever seen a box? When you open up a box, okay, you find out that you get something like this. Okay, which you can fold to get a box, and this is what we call nets. So this is a net of a geometric solid. So it's a two-dimensional figure that can be folded into a three-dimensional solid. So examples of nets: when you have a triangular prism and you open it up, you have something like this. And you have a rectangular pyramid and you open it up, you have something like this. So those are the nets. And you realize that for this rectangular triangular prism, there is a rectangle, a rectangle, a rectangle, and two triangles. When you fold them, you get this. For this one, there is a triangle, 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 and a square. So this is the net of a cylinder. It has two circles and a rectangle or a square. And this is the net of a cone. It has this and that. When you put them together, you get a cone. So let's look at a worksheet. Let's look at an example or a calculation using of solid plane figures. So the surface area of solid is the total area of all faces of a solid. We can use a ruler to measure the sides of squares or of solid plane figures once you open them up. So you can measure in millimeters, centimeters, meters, or kilometers. Okay, so for instance, you can check the length of this side, 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 this side, this side, and all the sides to know. Also the same thing, you can check the length. So once the length can be checked, it means that the area can also be calculated. So area of four triangular faces plus area of rectangular base. So if you know how to calculate the area of a triangle, then it means that you can calculate the area of this triangle, calculate the area of this triangle, calculate the area of this triangle, and calculate the area of the rectangular base. Same way, if you know how to calculate the area of the rectangle, you calculate this one, calculate this one, calculate this one, and calculate the area of the two triangles. Then you add them all together to get the area, the total surface area of the prism or pyramid. So surface area is just the area of all the surfaces around the prism. So you add the area, when you calculate the area of the individual shapes, you add them together. Example: calculate the surface area of a pyramid shown here. So we have the one side of the pyramid to be 13, another side to be 10, and another side to be 10. So let's see how the calculation is done. So when you open it up as a net, this is how it's going to look like. Okay, so this here is 13, here is 10. And for solid plane figures, once you have the sides, you realize that all of them are the same, so every part will be. So for example, here is 13, meaning that here will also be 13, here will also be 13, here will also be 13, here will be 13, here will be 13, here will be 13, here will be 13. Okay, here is 10, meaning that here will be 10, here will be 10, here will be 10. So that is what it means. So in order to calculate the area, you can calculate the area of the square base here, and this is what we get. Area is length times breadth, and this is a square, so length times length. So 10 is here and 10 is here, so 10 times 10 is 100. Then we now know the area of the base. Now we are left with the area of the triangles here. Once we calculate one, then we already know the rest. Okay, so let's calculate the area of this triangle. Now area is calculated by the formula half base times height. Okay, half base times height. So once you know the height, which will usually be given to you, then you can actually calculate the area of the triangular face. So for instance, let's say our height is 12. So if our height is 12, then half times base times height, then it's half times, what's the base? The base is 10, the base over here, times 10 times 12. Our height has been given to us as 12. So you add them, you have 60. So then in order to find the total surface area, this area is, we've calculated this area to be 60. So the same thing will apply here. Here will also be 60, here will also be 60, and here will be 60. So you add all these 60s together, that's 4 times 60. That is 240 plus the area of this rectangle, which is 100. Okay, so 240 plus 100 is 340, and that's the total surface area. So that is how the total surface area of solid figures are calculated. So you can actually take a look at this prism and how when you open it up you get the nets and you can calculate the total surface area for them. Okay, so this is the end of our topic on prisms, and I've given some questions and I hope this video will help you answer them. Until we meet again, have a nice day. Bye bye.